This course in digital logic requires a little bit of basic circuit theory. We don't need a lot, but let's get started with some basics and we'll fold more in as we need it. All right, so the first thing I want you to think of is a voltage source. All right, and what I'm going to do here is I'm going to draw a picture of a battery, just a AA battery. A AA battery, I think it's 1.5 volts, but let's not worry about that. Let's call it 5 volts. All right, so the battery source is 5 volts. 5 volts is a typical number that we use in digital logic, even though it's a little bit obsolete. Anyway, we're going to connect that to a resistor. The job of this resistor is to control the current going to an LED. All right, so I'm going to draw an LED. This is the symbol for a diode. Sometimes people put a circle around it to show that it's an LED. Okay, LED stands for light emitting diode, and so the nice thing that I like about that is it shows the dependency on current. Okay, so this is a basic loop circuit, all right, and Ohm's law says that voltage is equal to current times resistance, and then also what we know from Kirchhoff's voltage law is that when we traverse a loop around a circuit, so if I go from here to here, all right, I have a rise of V volts, so that shows up here, and then I have a drop of I times R, and then we're just going to assume that the voltage drop across the diode is 0 volts. That's not quite right, but it's close, all right? All right, so I now have the theoretical setup here, and what I want you to get out of this is that with something like a voltage source, we hold this constant, all right? And typically, we would vary the load, all right? So later on, we're going to talk about logic gates. We'll talk about ideal logic gates where the loading doesn't actually matter under ideal conditions. And I just want you to get a sense of what happens with a single loop circuit. All right, so if you take R and you increase it, all right, well, what we know is that V equals I times R. I can solve for the current. The voltage is fixed, and we're going to put in different load values. All right. So if I increase R, then what is that going to do to I? All right. As I increase R, I would be actually shrink. All right. And so what would happen with the LED is that it would dim the LED. All right. So you might be asking, what's the function of R? Well, if you have an LED circuit, if you just put R equals 0, you'll get essentially infinite current because, V divided by R equals 0, the math predicts that it would be infinite current. It wouldn't actually get to infinity because it would blow up the diode, all right, and smoke the diode. So the reason we have R in this little simple loop circuit is to keep that from happening. All right, so as we reduce R, all right, if we don't, you start with a value of R where the LED comes on. As you reduce R, I actually increases, all right, and that would make the LED brighter. All right, so this is the basics of Ohm's law. We're going to talk more about circuit theory as we move through the course.